All right, in this video we get to delve into the wonderful world of factoring again. But now we're going to be factoring in these special circumstances where we have the difference of two squares, and we often call them perfect squares, okay? So difference should tell you right away that we're talking about subtraction, and there's two squares. That means two things that were square. We're not talking about like the shape of a square, but basically squaring means something times itself. Factoring is the reverse of foiling, okay, or multiplying polynomials together. So we're looking for the general form of the difference of two squares is that you have something squared minus some other thing squared, okay? And if you recognize that your polynomial that you start with looks like this or is in this form, you can factor it out pretty straightforward because it's just a plus b and a minus b. So whatever this was squared, it's that plus the other thing that was squared multiplied times the root minus the other one. Now, you might ask yourself, how in the heck did this happen? Well, let's look, okay? If I were to take these two that I say is the answer, I claim that this factored is this. So that means that if I FOIL this, I should get this, right? They're reverse of each other, but they're equal to each other, okay? This is just a simplified form of this. So let's look. If I take a times a, that's the f, I get a squared. Outside, a times negative b is a negative b and a, but since we multiply them, we put them in alphabetical order. Positive b times a, so this was like a negative b times a, and this was a positive b times a. You could think of it that way. And then b times b is b squared, and a positive times negative is a negative. So then when you write it all out, you get a squared minus ab plus ab minus b squared. What happens to the minus ab and the plus ab? Well, if you have a negative 7 and a positive 7, they cancel to be 0. Or a negative x and a positive x, they become 0. So that middle term ends up going away or turning into 0. And so guess what you have? A squared minus b squared. So there's your proof. A squared minus b squared factors into a plus b and a minus b because the middle term ends up equaling to 0. So let's look at an example. Something squared minus some other thing squared. So what's squared here? X. What's squared here? 2. So my a is x, my b is 2. So I have a minus b and a plus b. You could have written it as x plus 2 times x minus 2. It doesn't really matter which order. You're going to get the same answer. So let's look at this one. A squared. What squared is here? Ooh, this is a 9, and this is an x. So 9x squared will give me this. 7 squared will give me this. So this is in the form of a squared minus b squared. So if I want to factor this out, I can recognize it. If I recognize that it's in that form, then it helps me a lot because then I can say, oh, it's just going to be this a plus b and a minus b, again, in any order. Now to use this, it has to be a perfect square. In other words, the whole term must be broken down into something squared, and the whole term. We can't have any pieces, parts in either side that doesn't, that isn't part of the square. Also, it has to be a subtraction sign in here. If there's an addition sign in here, then that middle term won't go away, and you end up having to use the quadratic formula or something different, okay? So you might want to memorize all this perfect squares for 1 through 15. You probably already know 1 through 10, but here are 11, 12, 13, 14, and 15. Those might be helpful. But you can always check it in your calculator when you're on the test. You can, or on your homework or whatever, you can just try numbers and see if they give you that number. See if it's this special case. Okay, so here's some non-examples. That means these are not counted as perfect squares. So this is not a perfect square, or difference of perfect squares. The reason is because this one is, but what about 5? Nothing times nothing's going to give you 5, okay? What about this one? Ooh, 25 is perfect square because it's 5 times 5, but this is an odd exponent. So when you have variables that have big exponents like this, remember x to the something squared, and this is just an a, any number, that means you end up with an even number in your exponent, right? So an odd number is not going to help us out. So this one's not the difference of perfect squares because of that odd exponent. What about this one? What's wrong with this one? The plus. You can't have a plus. It's the difference of perfect squares. Okay, so they have to be subtracted. All right, so I want you to try these. What squared is 9? What squared is 16x to the 10th? And then factor it out into a plus b and a minus b. What squared is this? What squared is this? And factor it out into a plus b, a minus b. Okay. Here we go. You're looking for perfect squares? Perfect squares. Remember, if it's even, right? There's 5x's times 5x's. That'll give you 10x's. That's the same as squaring. Squaring just means multiplying by yourself. Okay, same thing here. The more practice you do, the easier it is to identify what would be your A and your B. So a lot of practice really helps, even though it seems like a lot of work. Just makes your life easier later on. Okay, so let's talk about these. What if you have a greatest common factor first? Again, we're starting to put things together. So if you can simplify an expression that you first start with the greatest common factor, do it, okay? Because the lower the numbers are that you work with, the easier life is. So I look at this and I say, oh my goodness, I need to factor this out. I got to figure out what we started with. Well, I notice that there's a 3 in common and there's an x in common, so I'll go ahead and factor those out. And when I say factor out, that means I'm dividing all the terms by 3x, because then I'm going to go back and multiply them. When I factor, the answer has to be it has to be equal to whatever I started with, just in smaller parts. Okay? Then I look at this and I say, what? This is a difference of 2 squares, right? I've got something squared, a squared minus b squared. What squared is 1? 1. Okay, so don't forget that one. A lot of students forget that one. Okay, so then I say 2x squared, so that's a, and 1 squared is b, so a minus b and a plus b. That's the simplest you can get. What about this? Can I factor something out of these? Well, I can't factor an x, but I can factor a 5. I know all 5s have 0 and 5. So I factor out a 5, right? Then I get a perfect square, difference of perfect squares. Here's my a, here's my b, a minus b, a plus b. I don't lose my 5, don't forget it. If you lose your 3x or lose your 5, you don't actually have a factored form. You've just changed it into something completely different. Okay? Now I want you to try these two. Okay? Hopefully you factored out a 2x, and hopefully you factored out a negative 18. If you had forgotten that and just factored out like a 6, then you would have seen that, oh, I can factor it again. You would have noticed that. Okay, what about if you have the difference of 2 squares, but then you get something that can also be factored even again, more and more and more. So basically, when you have variables that have the fourth or higher, the even numbers of variable exponents, oftentimes you can run into this situation where you can do the difference of 2 squares and then you get an answer, and then, whoa, you can do the difference of 2 squares again. So again, factoring is the simplest form. So sometimes you have to use 2 or 3 or 4 steps. So here we say, hey, this is a perfect square minus a perfect square. Okay, so this was x squared squared. This was my a, and this was my b. So then I factored into a minus b and a plus b. Okay, that's what's written over here. So, but then when I get my answer, I notice this is a perfect square again, and this is a perfect square again. So my a is x, and my b is 3 this time. So I can keep factoring. It can be simplified even more. This one cannot, because there's a plus sign there, right? And that messes everything up. So this is as simple as it can go. But the difference of squares showed up again. So since there's an a and a b, then I say a minus b and a plus b, and I leave the third one. So all 3 of these together is the factored form of this one. Okay, so I want you to try it. Figure out what a is. Figure out what b is. factored into a plus b and a minus b, then look again at your a minus b to see if it can be factored again. And guess what? It can. Okay? Okay?